Hello! For this playlist, we are going to talk about Laplace transform. This is one of those methods that will allow us to solve any differential equation. By using of Laplace transform, we are actually converting a differential equation into an algebraic equations with variable of s. This is the use of the Laplace transform to make the process of solving the given differential equation easier. Okay, so we're going to come up with a certain process of transforming any given function, okay, into an equivalent form with s as its variable, and which is also true for some differential equations therein. We will have probably additional videos later on into the solution of differential equations using Laplace transform. But first and foremost, for this playlist, we are going to talk about what is the Laplace transform, what's the notation for the Laplace transform, how do we transform or how do we get the Laplace transform of any function, and the process therein, and some examples as well. So for the Laplace transform, it is related to any function. Let's say here function of t or f of t. Of course, you can use f of x, but generally for these situations, we're considering f of t be defined. It is actually defined for all t greater than or equal to 0. The Laplace transform, oftentimes denoted by this, of our function of t, or other notations will use the cursive form of L, they mean the same thing, okay, is equal to the integral of the result of this integral. We have the integral of e to the power of negative st, and then your function of t dt, integral from 0 to infinity. So you're going to plug in here your function, okay, to get its Laplace transform. And take note here, we have two variables s and t. But the integral is actually for dt. That would mean we are going to treat s as any constant. That is why we are expecting that the function resulting from this is any function with s, because s will not be changed using the interval here 0 and infinity, because that is for our t. Okay, so this is how we are going to show the Laplace transform of any function f. We will have a lot of examples to this, together with the what they call the rule for functions. Let's say constant function, what would be the Laplace transform? What would be the Laplace transform for a linear function, for a quadratic function, cubic function, even for sub-exponential and trigonometric functions. We will have them on separate videos in this playlist. So if you would like to learn how to get the Laplace transform of any function, please stay tuned for some of the examples and rules that will be provided in this playlist. Thank you very much for watching.